Good day everyone, my name is Carmely and today I'm going to report to you the current and voltage laws. So as you can see, it is the German physicist known as Gustav Robert Kirchhoff. So in 1857, he established two laws known today as Kirchhoff's laws. These laws state the general restrictions on the current and voltage in an electric circuit. So these are laws number one, the sum of the potential differences or voltages in a complete circuit must be zero. This law is also known as Kirchhoff's voltage law. Law number two, at any specific instant at any junction in an electric circuit, the total current or amperage flowing into the junction is the same as the total current leaving the junction. This law is also known as Kirchhoff's current law. So first is KVL or Kirchhoff's voltage law is one of the two fundamental laws in electrical engineering. KVL is a fundamental law as fundamental as conservation energy in mechanics, for example, because KVL is really conservation of electrical energy. So the voltage law states that the relationship between voltage drops and voltage sources in a complete circuit. By convention, the voltage drops are assumed to be negative and the voltage gain is positive. And according to the law of sum of these two quantities in a complete electrical circuit is equal to zero. This means that the voltage drops around any closed loop in a circuit must equal the voltages applied. So next is Kirchhoff's current law or KCL. KCL helps to solve unknowns when working with electrical circuits. KCL with the addition of KVL and Ohm's law will allow for a solution of complex circuit. So according to the current law, when a charge enters a junction, it has no place to go except to leave. By junction, current flowing into a junction are assumed to be negative and current flowing out of the junction positive. And by this law, the sum of these two quantities is equal to zeros. So no matter how many paths into and out of a single junction, all the current leaving the junction must equal the current arriving at that junction. So Kirchhoff's current and voltage law indicate that the loads consume all of the power provided from the source in an electric circuit and that energy and charge in an electric circuit are conserved. Simply, energy and charge cannot be destroyed. These principles are known as the law of conservation of energy and law of conservation of charge. These, law, these laws are useful in understanding the movement of electricity through an electric circuit. So next is series and parallel circuits. Series circuit principles. Components in a series circuit share the same amperage, so the total amperage in a series circuit equal to the sum of individual amperages. So total is equals to L1 plus L2 plus L3 and so on. Total voltage in a series circuit is equal to the sum of the individual voltage drops. So E total is equals to E1 plus E2 plus E2 so on. So total resistance in a series circuit is equal to the sum of the individual resistances, making it greater than any of the individual resistances. So R total is equal to R1 R plus R2 plus R3 so on. So for parallel circuit principles, components in a parallel circuit share the same voltage. So the total voltage in a parallel circuit is equal to the sum of the individual voltages. So E total is equal to E1 plus E2 plus E3 and total amperage in a parallel circuit is equal to the sum of the individual branch amperages. So total is equal to L1, L2 plus L3, Ln. So total resistance in a parallel circuit is less than any of the individual resistances. So R total is equals to 1 over R1 plus 1 over R2 plus 1 over R3 and so on. The next topic is the relationship between magnetism and electrical current. So let us first define magnetism. Magnetism is a force of attraction between ferromagnetic metals such as iron, nickel, and cobalt, and force of repulsion between magnetic materials such as antimony and bismuth. A magnet displays the properties of magnetism. Magnetism is defined as the physical phenomenon produced by moving electric charge. Also, a magnetic field can induce charged particles to move, producing an electric current. So, for electric current, a movement of positive or negative electric particles such as electrons accompanied with such observable effects as the production of heat, of a magnetic field, or of chemical transformations compare alternating current, direct current, displacement current. So, like electricity, magnetism produces attraction and repulsion between objects. While electricity is based on positive and negative charges, there are no known magnetic monopoles. Any magnetic particle or object has a north and south pole, with the directions based on the orientation of Earth's magnetic field. So electricity and magnetism are closely related. Power lines generate magnetic field and rotating magnets is a generator to produce electricity. But the phenomenon is actually much more complicated because the electrical and magnetic properties of certain materials are also coupled with each other. The electrical properties of some crystals can be influenced by magnetic field and vice versa. This is known as the magnetoelectric effect, and it plays an important technological role, for example, in a certain type of sensors or in the search for new concepts of data storage. So that would be all from my report. Thank you for listening.